It's a great honor for me to introduce to you Professor Mark Bickhard. Mark Bickhard is the MBR Rules Professor at Lehigh University. He is affiliated with the departments of philosophy and psychology and 4 other departments. And he's director of the Institute for Interactive Studies. His work ranges from process metaphysics, emergence to consciousness, cognition, language, functional models of brain processes, to persons and social ontologies. And I won't go on citing his website or bio. You can look it up. And it switch to my personal story. Mark Bickhart's work and Mark Bickhard always have been a great inspiration for me, already for my dissertation. For instance, the book Knowing Levels and Developmental Stages was a great inspiration for my dissertation. Nobody would come up with such a title nowadays, I think, but it is good. And he has a very long list of publications and talks and invited addresses, and you can look it up on his website. You can click on it through gps2018.com. But I think it's more important that Mark Bickhard has been a long-time member of the society, and he's admired very much, so among the long-term Jean-Pierre Society members, and very rightfully so. Not just because he has been board member and served in certain functions, but because of his intellectual contributions. But at the same time, I must say that my impression is that for many people, they feel a bit unsure whether they can follow his intellectual exercises and deliberations. But that's not so strange, because Mark is discussing his topics with people from several fields at the highest levels. Like I said, he's working in robotics, biology, and so on and on. And it's difficult for us to keep track of all that, but he has to do that. And he does that. And I think that's good for him and for the society. He's playing on different chessboards, so to speak. And of course for us that's difficult to follow. And I think it's important for society because the Jean-Pierre Society wants to be an intellectually broad society with discussions with all kinds of people, not just people in psychology, for instance. And that's the reason why we, for this conference, invited people from outside the society, like for instance Karen yesterday with a great talk, and tomorrow a talk from Ezekiel Paulo, which I would be very much forward to. And but I think it's also important to have our own sort of the house philosopher, the in-house philosopher for the society, which is Mark. And he's telling us for many years now about this interactivist model, which I think most of us in a society would agree to if they really understood it. And I think it's also important having a house philosopher or one of the. I think it's true that for a philosopher, if you want to honor him, and there is no better thing to do than to disagree with him on almost anything. So that's the program for today. Very warm welcome for Mark Bickhard.
What a setup. Follow that one. Actually, in some respects, I am a philosopher, but I sort of backed into it because the kinds of questions I was interested in weren't really addressable within psychology. I took only one philosophy course ever, and I got a C in it. I didn't tell Lehigh University that till after they already hired me. Well, anyway, we'll see what we do. Dynamics is not enough. The contemplative approach. I owe this to Paul from yesterday. I'm frankly not sure what it meant, but it sounded potentially positive, so I thought I'd borrow it. But anyway, here comes something that he called the contemplative approach. A general overview, this is just a few of the high points to serve as sort of a conceptual skeleton for what I hope to do. I'm going to be arguing that a process metaphysics yields the possibility of genuine metaphysical emergence, which, as you may or may not know, is a real disputed issue within philosophy. Certain kinds of thermodynamic processes, in turn, yield normative emergence, which, according to Hume, is not even supposed to be possible, including function and representing, which are two that I will mention briefly. These models, in turn, force an evolutionary epistemology, a variation in selection epistemology, the term coined by Donald Campbell. And in turn, those yield models of learning and development, which is supposed to be our focal topic here. And then I will spend just a brief moment illustrating from a very narrow perspective how these kinds of processes might actually be realized in the brain. Okay, so the first question is, why metaphysics? Isn't that irrelevant? The empiricist framework that psychology works within, somewhat less now than a while ago, but is still dominated by, would say, oh, metaphysics, that's armchair stuff, that's not relevant to anything. Those people can go off and do their thing. Doesn't have much to do with how we do psychology. The trouble is that metaphysics frames and constrains, and sometimes forces, theory and methodology. And as the old slogan goes, everybody has a philosophy, they live it. Whether they reflect on it or not, well, every scientist doing their work has a philosophy of science, whether they know it or not, whether they can or think about it. And their background frameworks may or may not be serving them well. So it forces theory and methodology all the way down to experimental design, and I will wave my hands a little bit at a couple of examples of that to show you that it is relevant all the way down to experimental design. In which case a false metaphysics may do this framing and constraining and forcing and so on badly in distorting ways that make research less valuable than it might otherwise be. And actually we have some very good historical examples that everybody knows about. If you've got a background assumption of associationistic behaviorism where your fundamental unit of theory are these little hyphens, we know that that's not only false, but it simply cannot work in principle. So there's a historically important example in which background assumptions have misled a lot of work. And a lot of that work, who's going to read it now? It just is not directly relevant to what we think psychology is supposed to be doing. A contemporary example I would urge, I'm not going to do this full argument here, is information processing frameworks. And I would argue they make, in a similar way, although not the same, but in a similar way, they make foundational mistakes. And they're going to render a whole lot of work being done today ultimately not particularly relevant. Okay, so given that we need a metaphysics, and we have a metaphysics whether we know it or not, I'm going to be arguing for a process metaphysics. Why a process metaphysics? Well, the two on the table in contemporary work are particle metaphysics or process metaphysics. And particle metaphysics just ultimately is not acceptable, even though it's the dominant way that we think about it, because we think about the world as constituted by these little particles, electrons and so on. But there are both conceptual and empirical problems with this framework. Conceptually, point particles can't interact. They never hit each other. They have no way to repel or attract each other. Now, Democritus, from whom we get some of these things, knew that this was a problem, and his atoms, quote unquote, had little eyes and hooks on them so that they could hold together with these eyes and hooks. But he didn't have any particular explanation about how the eyes and the hooks are supposed to get together, and certainly no notion of anything repelling. And within a particle framework, this has been a problem all along. Newton knew about it. How do things come together? What makes them come together? Okay, and we could go on about about the conceptual problems. If we look at contemporary physics, a kind of an approximation that we think in terms of is that we've got particles, yes, but they interact via fields. So it's the fields that attract them to each other or repel them from each other. But fields are processes, and so that way of thinking about things has already given away what I consider to be one of the most fundamental issues here. But we can go even further. According to contemporary physics, there are no particles at all. And that kind of seems surprising to people who haven't kept up with this stuff. Instead, what there are quantized excitations, little wave excitations in quantum fields. And this quantization is about all that is left of any classical particle notion. Now, quantization, okay, maybe that even sounds like particles, but let me point out, if you have a guitar string and you pluck it, you have a quantized number of wavelengths. And the mathematics of the quantization of the guitar string wavelengths is almost identical to the mathematics in quantum field theory, and they are quantized for very, very similar reasons. But there are no guitar sound particles. And similarly, there are no particles in quantum field theory. So what we got with our best current physics is everything is organizations of and interactions among quantum fields, including space-time as a quantum field. And quantum fields are processes. So our best physics gives us a process physics, which at least supports, if not forces, a process metaphysics. Okay, what about dynamics? The title of this is Dynamics is Not Enough. What do I mean by that? Well, dynamics is a conceptual and mathematical framework for modeling processes, and in that sense it's quite apt to what I'm arguing for. But it's process in a very general sense. So like the steel balls in a box bouncing around would count as a process. And as a matter of fact, when you first read dynamics and the mathematics of dynamics, that's an example that's often given. So you've got for every steel ball, you've got a location, you've got a moment, so on, and you can create state space out of this, and then you can describe the kinds of trajectories that the overall system can go through, and there you have a dynamical model. Okay, but three balls in a box is not a process metaphysics, even though it may be process in a certain sense. Something's changing, something's moving. So what I would like to suggest by the title of Dynamics is Not Enough is that dynamics per se, without an underlying process metaphysics, does not necessarily, just in itself, support important further consequences of a process metaphysics. So let me say a little bit more about this underlying particle framework. Particle framework, as I mentioned, derived from Democritus. A substance framework, in a sense, derived from Empedocles, earth, air, fire, and water. Aristotle modified these, especially Empedocles, in critical ways. And that's gotten passed down to us over the last 2.5, 3 millennia. Process, in some respects, derives from, if not literally in a historical sense, certainly presaged by Heraclitus. So, one basic distinction between these two is, what is the most basic state? Is the most basic state stability? Notice particles are inert. They may move in space, but the particles themselves don't change. Earth, air, fire, and water don't change. So we get inertness as the basic condition out of both of these. Or is it change? Well, for Heraclitus, fire was the basic, and fire is a kind of changing. And these lead to very, very different conceptions. So in the Aristotelian view, derived from Empedocles, derived from Parmenides, actually, we have to have an underlying substrate for change. So the particles don't change, but their configurations do. The earth, air, fire, and water don't change, but their mixtures do. And this idea that you have to have an unchanging substrate for change is a kind of a one level deeper down heritage that we have gotten from the classical Greeks. And it is still with us in a very, very strong way. Now, I'm going to be arguing, and obviously already started, arguing against these substance and structure and particle ways of thinking about things. One side note is that we can sometimes use substance and structure assumptions heuristically and they don't do us any harm. So for example, iron is a furious process of quantum fields. An iron girder is an even more complicated, furious process of quantum fields. But the energy level at which an iron girder is rigid and has strength and so on is an energy level that is so much higher than the energy levels that are relevant when you're trying to build a bridge that you can just ignore all that quantum process stuff and treat the girder as if it's a structure with certain properties of strength, etc. And that's a perfectly good heuristic use of a structural approach. The reason you can do it is because the energy level at which the structure is a structure is much different from, much higher than the energy level at which you're trying to do something, namely model the strength of a bridge and the resistance of a bridge to wind and weight on it and so on and so on. So the energy levels that you're concerned with in building a bridge are so different from the energy levels at the underlying process that you can ignore the one in favor of the other. But if the energy levels that keep something stable in time, keep it going through time, are similar to the energy levels of the phenomena you're interested in, you can't do that anymore. So in a candle flame, the energy levels that keep the candle flame going are identical to the energy levels that constitute the burning of the candle flame, because the candle flame is the flow of process of burning. And so trying to treat fire as a substance doesn't work anymore. You can't treat the candle flame as phlogiston in the same way that you can treat an iron girder as a structure. And of course people tried to treat fire as phlogiston and it didn't work for lots of reasons. In some circumstances, however, substance assumptions can be successfully used heuristically, but I would argue that in no living being can you ultimately do that, because living beings are constituted as stable things at the same energy levels or very similar energy levels to the energy levels at which they're doing whatever they're doing, that makes them alive, that makes them thinking, that makes them developing. Here's a partial aside because of one of the questions that was asked. I'm not going to give an argument here, I just want to point to some things. An ultimate consequence of a process metaphysics is that there are no metaphysical particulars, and particulars being used in a technical sense here. But there are no ultimate atoms, there are no points, there are no event points. People, if you're interested in this kind of point, Johanna Seidt is one of the persons I would suggest you look at. She, in my judgment, is perhaps the best process ontologist working today. Richard Campbell has a recent book that is extremely good about this. Notice if there are, and just to give you another example of how these sort of foundational, seemingly armchair, irrelevant issues can have downstream consequences. If there are no events as particulars, then there is no causality between events or entities. And that's the way causality is usually assumed to be constituted. If there's no causality between events, then action cannot be successfully modeled as the initiation of such a causal chain. And if action cannot be initiated, cannot be modeled as the initiation of such a causal chain, then models of ethics based on such models of action are at best badly framed and grounded. And I would argue, in fact, that this undermines a huge swath of the literature on ethics. Of course, none of us care about ethics, but maybe we should. And if you do care about it, I would suggest not basing it on an impossible, an incoherent notion of action. Instead, what this kind of a framework yields is a relationalism, not a foundationalism. It's a relationalism of ongoing influences among ongoing fields and processes. They're always moving. This harkens back to the point I made of what's basic. Is it change or is it stasis? So if everything is always moving, you don't have this classical Aristotelian picture of something is stationary unless something hits it or something makes it move somehow or another. Everything is always happening. But what happens then is that some things that are happening here will modulate or influence what's happening here. And that sounds like a trivial difference, but it turns out not to be. Well, one of the things that I think is extremely important about moving to a process of metaphysics, aside from the fact that it seems to be forced by both logical and physics considerations, is that it yields a notion of emergence. And as I mentioned, emergence is an extremely contentious issue. The intuition of emergence is of some causally efficacious influence as a result of organization. I most of the time have causal in scare quotes here because I don't think causality itself is actually a metaphysical phenomenon, but I may or may not get into that. Nevertheless, it is used to refer to something. If this can influence that some way or another, we tend to talk about it as cause. Well, can this exist? Can we have causally efficacious influence from organization per se? The answer is no, if we've got a particle metaphysics. Yagwon Kim has famously argued this for some years, and I think his arguments are extremely good. They're contentious in some ways, and there are some problems with them. But I think the fundamental intuition is, look, if we've got particles, that's where the causality is. The particles interact with each other in terms of whatever their causal properties are. Organization, well, yeah, it sort of makes a difference, but it's like boundary conditions. Organization is not a particle. Organization is not a substance. It's not even a candidate to have causal power. And so one of Kim's arguments, not his most famous one, but one that I think that most reveals these assumptions, is what he calls causal regularities. He says, in effect, look, okay, you've got a bunch of particles. If started in this configuration, they may regularly yield this kind of flow, outcome, whatever. If started in this different configuration, they may regularly yield this other flow or outcome. So the configurations make a difference, but there's no causality there. It's just the particles doing their dance within, dance with each other within these differing starting points, these differing initial conditions. It seems to me it's a pretty good argument, but it doesn't work if you've got a field law or a process law. Fields modulate each other in ways that are essentially dependent on organization. And it's fields all the way down. There's no lower level at which you hit something like particles, because what we call particles are just wave excitations in these fields. They're part of the process. If that's the case, then you cannot delegitimate organization as a potential ground for causal power without eliminating causality entirely from the universe. So organization has to be a potential locus of new influence, of new causal influence. And if you've got new organization and some interesting new causal kind of influence, you've got emergence. And in a sense, emergence becomes trivial, at least as a metaphysical possibility, if you adopt a process metaphysics. Well, okay, if we've got the possibility of genuine metaphysical emergence, this opens up the possibility of some particular emergences. Simply blocking these conceptual reasons why emergence supposedly can't exist at all does not give us an account of any particular emergences. So here I'm going to suggest some particular emergences that depend on thermodynamics. And notice that thermodynamics is itself an intrinsically processual framework. Thermodynamics is basic to several important emergences. If change is always occurring, how can we account for anything that doesn't change? And our world appears to have things going on that don't change. So what is it about them that don't change? Well, what is it about them that doesn't change, I would suggest, are the organizations. So some organizations are organizations of process. So they're always changing because that's what process is. But they're always changing within some organization that remains relatively stable. And there are at least two kinds, actually there's more of them, at least two kinds of these stabilities. Two kinds in the sense of explaining them as being stable. One is what can be called an energy well stability. So an energy well stability is an organization of process that just keeps going in this organization because it's down in an energy well. And in order to change the organization of the process, you need to hit it with enough energy to knock it out of the energy well. So a good deal of our world is constituted by these energy well stabilities, like an atom. An atom is a furious process, but the organization that the atom is engaged in this process can stick around for cosmological time periods, billions of years, unless sufficient energy hits it to disrupt it. One of the things about these energy well stabilities, like atoms, is if you isolate them from the rest of the universe, they go to thermodynamic equilibrium and they're just happy. They can stay there for 1 billion, 10 billion, doesn't matter to them. An alternative kind of stability, however, is an organization of process that is intrinsically far from thermodynamic equilibrium, so this FFE thing up here. And we have lots of examples of those too. Candle flames, or you and me, interestingly enough. We are intrinsically far from thermodynamic equilibrium, and yet we stick around for a little while. And candle flames can stick around for a little while. But there's a very different phenomenon going on that undergirds, underlies the stabilities of these far from equilibrium conditions. And it's illustrated by the fact that if you isolate them, if you isolate the candle flame, it ceases to exist. If you isolate you or me, we cease to exist. We are the flow. The candle flame is the flow of oxygen coming into the flame, waste products going out, and so on. So if you isolate it, you interrupt the flow, and therefore you eliminate the process. That's a very different kind of phenomenon. Lots of things emerge as possibilities when we start looking at these far from equilibrium kinds of processes, including even just a candle flame. Notice, the candle flame does not have this flow when you first light the wick. The flow self-organizes. You don't wave the air in order to induce the inflow of oxygen. The candle flame induces that intrinsically in any kind of gravitational field. Because when it's burning, it induces convection, gets rid of waste products going up, and oxygen coming in, all kinds of things. Self-organization in general is a phenomenon that requires far from equilibrium conditions. And in general, far from equilibrium conditions will yield self-organization. So here we have two phenomena, two kinds of phenomena that are looked at in two different ways that are dependent, interdependent. Self-organization is itself a kind of emergence. Self-organization can be quite important, but there are also subcategories of self-organization that I suggest are, for us at least, even more important. One of those is self-maintenance. So the candle flame is not only an example of self-organization, it's also an example of self-maintenance. An example of self-organization that isn't an example of self-maintenance would be a chemical bath. You pump a bunch of chemicals in, and you get certain sorts of patterns that emerge that self-organize within the chemical bath. The maintenance of the conditions that produce that self-organization is completely external. It's the external tanks that hold whatever the reagents are. It's the pumps that are pumping it in. The self-organization makes no contribution to its own persistence. But with the candle flame, what self-organizes does make contributions to its own persistence.